general mathematics, when we add, subtract, multiply, and divide, it is better to have the idea that we don't just carry out such things with numbers. Instead, it is better to agree that we carry out such number operations with terms. It is not each time you carry out these arithmetic operations that you are dealing with pure numbers. Sometimes you deal with groups of numbers that are regarded as one number. On that note, I ask, what is a term? Further, what is an algebraic term? How do we know the number of terms found in a particular mathematical operation, especially with respect to algebraic expressions? That takes us to the fourth lesson objective of this lesson: the meaning of algebraic term. Please find out in this section as I explain the meaning of algebraic term and how to identify the number of terms found in a particular number operation. Please cooperate with me. Let us turn our attention to objective number 4. And what is it? Algebraic term. It is important that we learn what an algebraic term is before we start dealing with like terms and unlike terms. To start with, I ask, which of these two expressions is a term, an algebraic term? 5 plus 2 and 5 bracket 2. Which of them is an algebraic term and which of them is not? Or is there any one of them that is not, that is an algebraic term? Are they both not algebraic terms? Or are they both algebraic terms? Or is it that one is an algebraic term and the other is not? Anyway, if you don't know what an algebraic term is, you can't offer answers to these questions I just asked. Having said so, let me answer those questions and explain my answer. Let me inform you that this first one is not a term. Instead, it contains two terms. And this one is a term, just a single term. The implication, therefore, is that one of them is a term, that is one term, while the other is not. Please, let me write the answers to these questions corresponding to each of these two expressions. Please see. Now see the answers to the inquiries. 5 plus 2 is not a term. A means 1, which means it contains not just one term, instead it contains two terms. 5 bracket 2 is a term. That means it contains just one term. In other words, 5 plus 2 is not a term, while 5 bracket 2 is a term. You may still ask, what exactly is a term? The properties of 5 plus 2 and 5 bracket 2 will help you understand how to know whether a particular mathematical expression is a term or not. What are those features that expressions should possess before we call such expressions mathematical terms, which otherwise we call them not to be mathematical terms? This feature that makes a particular mathematical expression to be a term is contained in the definition of algebraic term, or just a term. That a term is algebraic is just an extended meaning. Here, we wish to first know what a term is, just ordinary mathematical term, before we speak about algebraic term. Let us pay attention as the definition of a term comes up. Please watch out. Now here comes the definition of a mathematical term. It says, a mathematical term simply means one number or group of numbers considered as one number. Is that definition clear to you? Can you make sense out of it? Anyway, let me use the foregoing two cases to explain the idea expressed in this definition. Before then, let us look at some of the important and high-sounding words and expressions that actually direct us to the meaning of this mathematical term. One of such expressions is one number. One number. That one number is either a constant number or a variable. Let me write some few examples of mathematical expressions that stand as one number, either constants or variables. See some examples of one number terms. 2 is one number, so 2 is a term. 8 is also one number, so 8 is a term. The command here shows that there is no connection between 2 and 8. The command is not a mathematical operation, so there is nothing connecting the 2 with 8. That shows that 2 and 8 are separate numbers selected for this case. Therefore, 2 is one number and is seen as a term. 8 is also a single number and is seen as a term. Then, both 2 and 8 are considered as constant one numbers. And then, what about x? It is also one number, but in this case, it is a variable. So one number is either a constant or a variable. 2 and 8 are constants and they are single numbers, while x is a single number but a variable. Each of them is considered to be a mathematical term. Do not forget that in this definition, we gave two different conditions that make a mathematical term what it is. It must be a number. If not just one number, then it must be a group of numbers that are considered as one number. That is, group of numbers, when put together, can be called one number. Let me give few examples of mathematical operations or mathematical expressions which contain more than one number joined as a group and considered as terms or one number each. Please let us see some examples. And here comes the second category of number expressions which we consider as terms. They are group terms. Remember that a term is either one number as expressed in this line or group of numbers, which we now want to consider. So this second group is called group terms. Examples include 2 bracket 8. Note that in the first case, 2 and 8 were separated by comma, and because of that, there was no number operation between them. In this second case, the same 2 and 8 are put together in a group. We now regard 2 bracket 8 together as one number. We now regard this 8x, 8 and x put together as one number. We now regard 3 cg as one number, and so on and so forth. If you watch, you discover that each example contains more than one number. This contains 2 numbers put together. This contains 2 numbers put together. This contains 3 numbers put together. We even have terms that contain 4, 5, and more numbers put together. What exactly is it that we have to see before we conclude that a particular mathematical expression is a term? We only saw 2 examples. Is seeing the examples enough for us to know what exactly we have to do to identify mathematical terms? I don't think so. More is needed. So please, how do we identify a mathematical term if we see it? First, this first part of the definition, which is one number, is not a problem. Each time we see one number written, we can take it as a term. So that one is not going to pose any case at all. The case lies with group of numbers considered as one. Does it mean that whenever 2 numbers or more come together that we can call them one number? The answer is no. So the problem lies with the way numbers combine before we can regard such group of numbers as a term. For instance, 2 is multiplying 8 here, 8 is multiplying x here, 3 is multiplying c and g, and each of them is a term. Does it mean that each time you see numbers that are multiplying, that in that case, we say it is a mathematical term simply because they combine by multiplication? Not necessarily. This is just an example. Fine. Multiplication of terms does not in entirety define what we call group term. So what then is a group term? Let us find out. The bottom line is this word, is this phrase considered as one number. When do we consider a group of numbers as one number? Please follow me as I go back to our prevailing cases. 5 plus 2 is not a term. Instead, it contains two terms, while 5 brackets 2 is a term. That is, it is just one term. What qualifies 5 brackets 2 to be a term and disqualifies 5 plus 2 from being a term? Why do we consider this, which is a group of numbers, to be a term, but this, which is also a group of numbers, not a term? Let me state the answer. Please follow through. And here it comes. We say a group of numbers is considered a term if a part of the group defines another part of the group, or the group undergoes a common operation. The high points of this statement are: the word defines. A part of the group defines another part and undergoes common operation. So defines and common, these two words are pertinent if we have to understand what this statement is talking about. To make this statement come alive, let us use these two cases at hand, the foregoing cases, 5 plus 2 and 5 brackets 2. Recall I said that this 5 brackets 2 is a term. That is, the two put together is a group of numbers, and the two are considered as one number. But in the case of 5 plus 2, it is also a group of numbers, but the two are considered separate numbers, not one. The question is why? Let me start with this second one, 5 brackets 2. If I interpret 5 brackets 2 and later interpret 5 plus 2, from their interpretations we can tell which one qualifies to be called a term based on this condition here. We now see which of them first is a group that contains a portion that defines another portion of the same group. Let's find out. Please permit me to interpret this and this. Now look at their interpretations. The first one is that 5 plus 2 is I have 5 and I have 2. Second one is that 5 brackets 2 is 5 twos. So I ask, with respect to the first condition, which is that one part of this group defines the other, please, in 5 plus 2, does 5 define 2, or does 2 define 5? Does any of them define the other? This statement, which interprets 5 plus 2, shows that 5 does not define 2 and 2 does not define 5. How? Having 5 has no link with having 2. Therefore, 5 does not depend on 2 and 2 does not depend on 5. The two are just independent of each other. But look at this, the second case. It says 5 twos. These 5 and these 2, are they also independent? The answer is no. They are interconnected. One defines the other. The reason why this 5 is put here is just to tell us how many 2's that we have. Therefore, since 5 defines how many 2's, the two numbers, though put together, are simply interwoven. It means that one portion of this group, which is this 5, defines these 2. 5 2's means that you bring 2 into 5 times. So 2 is the number, but 5 tells us how many times we bring that 2. Therefore, 5 defines the 2. That means that one part of the group defines the other part of the group. This 5, which is a part of this group, defines this 2, which is also a part of the same group. Consequently, 5 2's will not be considered as two numbers. Instead, the 2 put together will be considered as 1. Is the argument clear to you? Just think about it again. 5 and 2 in this first case are independent of each other. 5 does not know that 2 exists, and 2 does not know that 5 exists. It is only man that will say 5 joined with 2. That joining is not what I mean by 1 that defines the other. That joining is just like number operation, ordinary number operation. Therefore, of these two expressions, it is this that we regard as a mathematical term. Next, I ask, can something qualify 5 plus 2 to become a term? As it stands now, the 2 together are not a term. I ask, can something be done to make them become a term? Yes. How? It is in connection with second condition. The group undergoes a common operation. If 5 plus 2, though being different, undergo a common mathematical operation, the 2, although being separate, have been joined to be a term. Let me give an example. And here comes the example. We state that 5 plus 2 are separate terms. That is, in this expression, 5 plus 2, 5 and 2 are separate terms. But in these expressions, 5 plus 2 all over 3, bracket 5 plus 2, then square root of 5 plus 2, and such like operations, the 5 plus 2 has become a term. Why? Don't forget that we said earlier that this 5 plus 2 is not a term, but in each of these operations, the same 5 plus 2 keeps occurring, and anywhere it occurs, we regard it as a term. We ask, why this time around? It is because it has met with second condition. That condition is that the group together must undergo a common operation. For instance, here, 5 plus 2, though being separate, together as a group, is now being divided by 3. It means that 3 divides both 5 and 2. Because this 3 divides both 5 and 2 at the same time, it means that both 5 and 2 are receiving a common operation. Based on that, regard this 5 plus 2 as a term. Though before, without any other operation occurring on it, we had to regard the thing as just separate terms. What about this? Bracket open, 5 plus 2, bracket closed. This is also a kind of a term. Why is it so? Because there is an invisible 1 here, which multiplies both 5 and 2. It simply means 1 times whatever is in this bracket. Because 5 and 2 together are being multiplied by 1. It is not composed that 1 should be here all the time, but 1 is the least we can think of. If 1 is here as its coefficient to the bracket, we don't normally write it. When 1 becomes the coefficient of a number, we can leave it alone and write just that number. So 5 plus 2 in bracket has 1 as its coefficient. Because of that, we choose not to write it, but know that 1 is here. So because 1 is here, 1 is multiplying 5. The same one is multiplying 2 to open this bracket. Because both 5 and 2 are under the same or under a common operation, we regard 5 plus 2 in bracket as a term. What about this? This square root is not square root of only 5 and not square root of only 2. It is square root of 5 plus 2. Therefore, this square root is a common operation that is being carried out on 5 and 2. So because of that, the 5 plus 2, which when separate were seen as different terms, has become one term because one common operation is now being carried out on both of them. Such like operations can be carried out on 5 plus 2 and similar expressions to make them turn from non-terms to terms. I have just one more challenge before I go on to summarize the kind of the properties or features that we have to see in number operations or expressions before we conclude that they are terms. What challenge is that? Please be on the lookout. And here comes that challenge. The challenge is a quotient, 15 over 3. This is a group of two numbers, 15 on top and 3 below. How many terms do we have here? Do we have 2 terms? Do we have just 1 term? Do you still remember how to find out if a group of numbers is a term or not? I believe you do. Okay, answer me. 15 over 3 as a group, does it contain 2 terms or just 1 term? Anyway, let me interpret it. After I interpret it, you will tell me whether it is a term or not. On your own part, can you interpret 15 over 3? Let me give it one of its meanings. The meaning of 15 over 3 is 3 in number. It has 3 meanings. One of its meanings is how many 3's in 15. That is, somebody, if he says 15 over 3, he's simply asking you how many times you can get 3 out of 15. Now, at this point in time, I ask again, is 15 over 3 a term or is it containing 2 terms? To get to know, find out if one defines the other. If one disappears, is the meaning still complete? 3 and 15, are they independent in the way they relate in this expression? The answer is no. They are dependent on each other. If we are asking how many 3's in 15, obviously, one defines the other. One moderates the other. 3 and 15 are interdependent. Because of that, 15 over 3, and of course, all other questions we're going to see are considered as terms. So the first is a sum, which we consider not to be a term, but a group of terms. 5 brackets 2, which is a product, was considered and is still considered a term. Now, a quotient, 15 over 3, and all other quotients are considered as terms. Let me restate that anytime a group of numbers appears and each number in the group is independent of others, in which one does not depend on the other, please call that expression a non-term. Instead, it is a number of terms that make up that expression. But if one part or one number out of the group defines the other, then that group is considered a term. Let me now outline some kind of general number expressions and operations that are considered as terms. Please watch out. All right, here we have expressions considered as single term. That is, expressions which, when we see, are to be considered as one term. All products of all kinds are considered as terms. 3 times 2 is a product and is considered one term. 5y is 5 times y. It is also a product. It is considered a term. The same thing is applicable to xy, 10xyz, 5 bracket x minus y. You might ask, is x minus y not a difference? Why is it going to be a part of this product or a part of this group and is considered 1 with this 5? Later, in this number 4, we're going to see why we regard this as a kind of one term. After all, even before then, is this not a product? A bracket is considered as one number and then 5 times the bracket. So even if we don't come to this number 4, we can still conclude that this is one term because it depicts a product 5 times whatever the bracket contains, and so on and so forth. Just know that each time you see a product, you should consider it a single term. Next, number 2 is quotients. The quotient is an answer we get after division. Look at it, 5 divided by 2. Right, I just a short while ago told you why quotients should be considered as single terms. The next is x over 2, c over x, 7b m over 3, and such like expressions. All the quotients of all kinds are to be considered as single terms. Number 3 is the simplest of all, and it is single numbers. A single number is considered a term. 9 can stand alone on its own, and then we call it a term, whether it has an operation it is taking part in or not. Once it stands out, either as a part of a group or in isolation, we call 9 a term because it is a single number. 20 is also a single number and it's also said to be a term. The same thing applicable to x and p. X and p are variables. 9 and 20 are constants, but each number there is a single number. Such like numbers, single numbers are to be considered as terms. The last but not the least is sums and differences under common operation. A short while ago I explained this, and then we have more examples here. 5 plus 3 is a sum. Ordinarily, it should be a non-single term. 5 and 3, ordinarily, without this bracket and 2 coming before the bracket, should be considered as containing two terms. But because of the way they appear in this expression, 2 bracket 5 plus 3, please, 5 plus 3, though being separate, come under the same operation of times 2. 2 is multiplying both 5 and 3. That means that they are under a common operation. Based on that, the whole of this is considered to be a single term. What about this 7 minus 2? Ordinarily, 7 minus 2 is to be separate terms. But because 7 and minus 2, 5 is dividing them at the same time, it means that the two are under a common operation. Division is that common operation that 7 and minus 2 are undergoing. That is why the entire expression is considered to be one term. I hope you are following what I'm saying here. The next is this x plus y. X plus y is sum. Without this bracket and this is square, the x plus y should be considered separate terms. But because this bracket raised to the power 2 has been introduced, it thinks that this power 2 is affecting both this x and this y. Based on that, because the x and y are under a common operation of this raised to the power 2, we say that x plus y, though being separate, can now be considered as a single term. The same thing is applicable to 2m minus x, and such like expressions. Before we come to the end of this section, let us learn how to tell the number of terms that a particular mathematical expression contains. All right, let us use these expressions to tell or to learn how to find out the number of terms in a mathematical expression. Look at the first one, 2 minus xy plus 1 plus b bracket 8 minus c. My question is, how many terms are there in this expression? Is it 2? Is it 1, 3, or more? Please, what you think? Don't forget what you should see in a mathematical expression to call it one term. All right, this is 2 minus xy. At least that is a difference. And that difference is not one term. Sums and differences that do not possess a common operation, that do not come under a common operation, are not terms or single terms. Instead, they are a collection of terms. In fact, many mathematical expressions are terms. But if you want to know whether the expression is a term or not, check whether it is a sum or a difference in isolation. If you see a sum or a difference that does not come under a common operation, that is not a single term, but a number of terms joined together. Now, 2 minus xy is not one term. Why? This is a difference, a sum. But what about this b bracket 8 minus c? 8 minus c is a difference, and 2 minus xy is also a difference. Yet, all of these make up one term, but these two do not make up one term. Why? It is because these two do not come under one common operation. It is a difference that does not come under one operation, but this is a difference that has a common operation, that is b times 8 and b times minus c. Since 8 and c come under the multiplication by b, a common factor multiplying 8 and minus c, b is here. Based on that, 8 minus c, though being a difference, is a part of a product. So the entire expression is a product. Okay, so in all, this is a term. The next is xy. Is xy a term or different numbers? X and y are two numbers. They make up a group. Is xy a term, just one term, or it contains different terms? Xy is a product, and all products are terms. Therefore, together, xy is a term. So 2 is a term, and xy is also a term. So far, we have 2 terms. Next is plus 1. This is plus 1. Xy plus 1 is not a product. It is not a quotient. It is not a single number. It is a sum, and that sum does not come under a common operation. That is, xy plus 1 does not come under a common operation. Based on that, plus 1 is independent of xy, and xy is independent of this 1. Because of that, this plus 1 is a separate term. So far, we have this, and this as terms. What about the remaining one? I said earlier that it is the entire expression, b bracket 8 minus c, that is a term. So in all, how many terms do we have? Somebody who is not informed may think that we have 1, 2, 3, 4, 5, 6, 7 terms. Anybody that has not been taught about terms will say that there are 7 terms, simply because there are 7 numbers that feature in this expression. But because you have been told how to know what a term is, I believe that you can tell that we don't have 7 terms here. Instead, how many? 1, 2, 3, 4 terms. So there are 4 terms in this first expression. What about this second one? 2xy. 3 numbers feature in this expression, 2, x and y. Please, 2, x and y, do they feature in a sum? The answer is no. Do they feature in a difference? The answer is no. If they had been featuring in a sum or a difference that does not come under a common operation, we would have said that they are separate terms. But here, what do you think is connecting the 2, x and y? It is multiplication. That means that 2xy is actually a product. All products are terms, and 2xy is a product. Therefore, 2xy is just one term. So in this second case, we say that this expression contains just one term. I hope the line of reasoning is clear to you. What about this number 3? We have 5 plus 3x minus 7. Somebody who is not properly taught and is asked to state how many terms that there are in this third expression will say that there are 1, 2, 3, 4 terms. But do you think that there are 4 terms in this expression? The answer is no. First is 5. The next number is 3. This 5 and 3, are they together in a product? No. Are they together in a quotient? No. Are they connected by a sum? The answer is yes. Is there any common operation that they come under? The answer is no. Because of that, 5 is separate from whatever comes after it. Therefore, 5 is separate. That means we count 5 as a term. Next is this 3x. 2 numbers make up this 3x, 3 and x. Is 3x made up of two terms or just one term? You ask again, 3 and x, are they connected as a product? That is by multiplication. Is 3x a quotient? Is 3x a product? Is 3x a sum? Is 3x a difference? Of course, we can see that 3x means 3 times x. Therefore, 3x means a product. That is, 3x is a product. And all products are terms. Because of that, together, 3 and x make up one term. Next is this minus 7. After this 3x, what comes next is this 7. 3x and 7. Are they connected by, are they linked as a product? Are they linked in a quotient? As a sum or difference? Obviously, the link between 3x and this minus and this 7 is a difference. And between 3x and 7, we have minus, showing that the two are simply connected by a difference. And there is no common operation that 3x minus 7 come under. Based on that, 3 is independent of 3x and 3x is independent of this 7. So 5 is independent of 3x and 3x is also independent of minus 7. Because each number here is independent, each of them is said to be a term on its own. So instead of 4 terms being in this expression, I think at this point in time we have seen that what we now have is how many terms? 3 terms. 1, 2, 3 terms. The last one is this. Square root of 3 brackets x minus 5 all over 7. This root actually covers everything. Even if x minus 5 is a difference, and you have over 7 already. Even without this root, already x minus 5 no longer will be considered as separate terms. Instead, they are going to be considered as one term. Why? If you say over 7, it means 7 is dividing the difference. That alone qualifies x minus 5 to be a term. But we have further proof. What is it? Everything in this expression comes under a root sign. Because the root sign is another common operation to the entire thing, we now say that though complex to an extent, this entire expression is just one term. Alright, the time has come for you to check if you have been following what I've been saying from the start of this section till this point. And here comes the checkpoint. It says determine, hence state the number of separate terms in the following expressions. We just have 8 expressions. 1, just 7. Tell us how many terms there are in it. 2, 7 minus 2x. 3, 9 plus xyz plus 2. Number 4, square root of 9 plus xyz, then plus 2. Number 5, x to the power 2 minus square root of 1 plus y. Number 6, 3px minus 2xb plus, in bracket, y plus 1 all to the power 2. Number 7, square root of q to the power 2 minus 1 over x plus 1. Number 8, x minus 1 bracket x plus 5 bracket x minus 3.